Greetings, math fans. All right, this is Chapter 3, Day 2 notes. And basically what we're going to do is learn, these are a bunch of different applications. All right, so let's start with the first problem here. A gear rotates around 15 times. And remember, this is just another way of saying, instead of 15 times, you can say 15 revolutions. Or another word is rotation. So kind of keep that in mind when you see that. It says through how many radians will it turn? Well, here it is. It's 15 rotations. We'll call it rotations. And right, this is using our dimensional analysis. And we're going to say through how many radians will it turn? Well, remember 2 pi radians is 1 rotation. So that's what it is. 2 pi radians per 1 rotation. Okay? And then, of course, this is over 1. The rotations cancel, and we just have radians. And our answer is 30 pi radians. Or, right, if I ask you for decimal, 94.2478 radians. Okay? It's pretty easy. All right, this next formula here, it's actually really super important formula. It's S equals R theta. That's the arc length. Okay? And R is equal to the radius. And theta is called the central angle. And I'm going to put this in red because it is super important. This must be in radians. That is so important. It's got to be in radians. Always, either the output is going to be radians or the input is going to be radians, but it always has to be in radians. That's just super important. Okay, so let's actually use this now. Let's move on to problem number 2 here. Okay, the radius of a car wheel is 12 inches. It makes 1 complete revolution of the wheel. Find the arc length. Okay, again, it's really easy. And it makes 1 complete revolution, so we just have to use 1 complete revolution, which is 2 pi. So S is equal to R, which is your radius, times 2 pi, again in radians. And so the arc length is 24 pi. And so you can say 24 pi inches. Okay, all right, that's pretty reasonable. All right, so let's look at number 3. Find the radius given the following diagram. Okay, so now I'm actually giving you guys the arc length, and I'm giving you theta. But notice theta is in degrees, so you got to do a conversion here. So let's do that right off the bat here. Theta is equal to 135 degrees. And you might now already know that because we talked about it already, but let's just convert it. Pi over 180, right, that's the conversion. And we get 3 pi over 4 radians. Okay, so our equation is S equals R theta. And that's a good thing. Whenever you see something with arc length, just write the equation down. S equals R theta. It really helps out a lot. All right? And I'm giving you the arc length. So 6 pi is S. And I'm looking for the value R. And theta is 3 pi over 4. Okay, so we're solving for R. So, 4 over 3 pi, 4 over 3 pi, and the pi's cancel, and that's 1 and a 2, so R comes out to be 8. Okay, and I don't have any units here, so it's just 8. Okay, so that's a pretty basic example of using S equals R theta. Let's do a problem. All right, Madison, Wisconsin, and Hoffman Estates, Illinois are on the same north-south line. Madison is 45 degrees north of the equator, and Hoffman Estates is 40 degrees north of the equator. Find the distance between the cities. So this is what the deal is. Make a quick sketch here. This is the Earth. All right? And I'm going to give you actually, I have to give you a piece of information here. And I don't expect you guys to memorize that. But this is what you're given. Because obviously we have, it's S equals R theta. I got to give you the radius of the Earth because you don't know that. So radius of the Earth is equal to approximately 6,400 kilometers. Okay, I checked it last weekend and dug a really deep hole and until I got the center. So I'm just kidding. I really didn't. All right, so radius of the Earth is 6,400 kilometers. So this is the deal. Here's the equator, and I'm telling you that Madison, Wisconsin is 45 degrees. So that angle is 45 degrees. That's Madison, Wisconsin. And Hoffman Estates, right here. I know it's not really to scale. Hoffman Estates. That is 40 degrees. Okay? And what you're going to do is, this is actually really key here, so I'm going to write this out. The cities are, in order to do this problem, the cities must be on the same north-south line. Okay, because it has to be basically on the circle. It can't be inside the circle and one on the outside of the circle. It's got to be on the same, the same circle. So you can actually do this problem with S equals R theta. Okay, so really what you need to do here is, what's the difference between these two? So one is 40 degrees, one's 45 degrees, and I can just subtract that because I need to figure out this distance right here, math fans. Right? I need to figure out that angle. So isn't that going to be theta is equal to 45 degrees minus 40 degrees? So it's 5 degrees. Do you guys agree with that? I hope. All right. And then that's of course theta in terms of degrees, which we'll have to convert to radians. So what we're trying to do is we're actually trying to find out the distance between those cities, and we're looking for, if we're looking for the distance, we're looking for S. That's your arc length, because that's the arc length on the Earth. Okay, so like that distance is the distance from some city over here to some city over here. Okay, because again, it's on north-south line. All right, so we're just going to write out here S equals R, 6,400 kilometers times theta. Now we could have 4 or 5 degrees here, or we could have converted it earlier, but we're going to do it right here. So 5 degrees, and then it's pi over 180 degrees. Remember, that's your conversion. That'll turn into radians. And then, of course, you are going to give me a decimal answer because, if I'm trying to find a distance, I want you guys to give me something in decimal. And that turns out to be 558.5 kilometers. Okay, that's the distance between the cities. So let's try another one here. The latitude of Anchorage, Alaska is 50 degrees north. Anchorage is 400 kilometers north of Seward. What is the latitude of Seward? Okay, so now we're looking for an angle, right? We're looking for degrees. So if I draw a picture here, great Earth here, all right? And it says this is the center here, and this is Anchorage, Alaska. And Seward, Alaska, so that's here's my equator, and that is 50 degrees, right? 50 degrees north. And Anchorage is 400 kilometers north of Seward. So if I draw another line here, this arc length, because now I'm giving you the distance between them, so this arc length right here, which is S, that is equal to 400 kilometers. All right? And then it says, what's the latitude? So I really need to do is I need to figure out, at this point right here, I need to figure out that angle right there. Okay, we know it's 50 degrees to Anchorage, but I'm trying to figure out Seward, Alaska. Okay, so basically what I need to do is I need to find theta between the cities. Okay, if I find theta between the cities, then I'm kind of good to go here. So S, we know it's 400, equals R, that's given, right? That's 6,400, and times theta. And remember, that's going to give us that red mark I just marked here. It's going to be black now. That's going to give us theta between the cities. Okay, and if I divide by 6,400, theta comes out to be 1 over 16. And of course, that's radians. And remember, so the input is radians and the output is radians. So of course I need degrees because I need to figure out how far it is away. And if I convert that by multiplying that by 180 over pi, that gives us approximately 4 degrees. Okay, so that little mark right here, that red mark that I drew, that's 4 degrees. So if Anchorage, Alaska, let's just kind of draw a quick picture again. If this is Anchorage, Alaska, which is 50 degrees, and this arc is about 4 degrees, isn't Seward, Alaska, going to be 50 degrees minus 4 degrees? So that's going to be 46 degrees. Okay, and it's actually 46 degrees north, right? Well, it's not bad. All right. Next type of problems is called subtend. It's a word that you guys probably don't use. But what subtend is, I'm going to put a good definition here, when a central angle intercepts an arc, the arc is said to subtend the angle. Okay, so real quickly, I'm going to put one more little thing here. If the central angle is very small, then there is little difference between the inscribed chord and the arc. Okay, so let me kind of explain here what it is. I can actually move this up a little bit and so I can draw a little bit on top. All right, what I want you guys to do is I want you guys to think, and hopefully this will help you out a little bit, but when you are looking at a plane way, way far in distance, right, you can take your finger and if you want to like squish that plane, right, it's way far and it basically fits, you know, an inch in your fingers and you just go crunch and the plane gets crushed in your fingers. Okay, that's kind of what subtend is. And so let me give you an example here. This is, you're standing right here. All right, and here's the plane. So you're holding your fingers really close together and here is the plane. Very nice, it's a very high performance plane. That's the tail. All right, and what this is, you have an angle here, theta, and this is really, of course, it's an arc. So let me draw that again. This is really an arc here, right? Because it's basically part of since it is part of an arc, it's part of a circle, that's a curve here. But what the deal is, because that angle is so small, this angle is going to be super small. Then I could actually treat this, instead of an arc, I can treat this as a straight line. Okay? So that's kind of what the deal is. So it's a straight line and it's an arc. It's kind of all the same stuff. So that's why I can use S equals R theta, because actually it's not, I can treat it as an arc. It looks like it's a straight line because isn't that what a plane is, right? A plane's kind of like a straight object, and I can treat that as that it's curved, and that's why I can use S equals R theta to figure out that. That's what subtend is. So let's try it. Actually, let's do this problem here. Number 6. A cruise ship is 1,000 feet long. It subtends a 2-degree, 28-minute angle horizontally. How far is the ship out at sea? Now, people always get this confused, and they think that your R is this 1,000 feet. This is what the picture looks like. And here is the arc. but this is 1,000 feet. That's how big the ship is, right? Technically, again, it's straight like this, but we're going to use it as an arc because it's really close to being an arc, or it's really close to being straight. They're so close in measurement. So that's 1,000 feet, and usually this guy right here, how far is the ship out to sea? That is going to be your R. So usually the distance away, that's an R. And then, of course, your theta is going to be 2 degrees, 28 minutes. That's your angle, your subtend angle. All right? So let's use S equals R theta, and we're looking for R. So I'm going to plug in everything. So, of course, S is 1,000 feet. And theta is 2 degrees, 28 minutes, and then I got to convert that into radians because I'm going to input that in there. So it's pi over 180 degrees. So you get theta comes out to be 0.04305 radians, approximately. All right, and you're going to keep that number in your calculator because what you're going to have is, if I plug all that in there, I get 1,000 equals theta, which is 0.04305 times R. And that number is still in your calculator, so what you're going to do is you're going to divide both sides by that. And so you're going to say, in your calculator, in your graphing calculator, you're going to say 1,000 divided by answer. 0.04305. That's the best way to do it, as opposed to typing the, cutting off that decimal, keep it in your answer. So 1,000 divided by answer, and you're going to get R comes out to be 23,228 feet, which is approximately 4.4 miles. Okay? Now this is the deal. If you made a mistake, and let's say you forgot to convert it to radians, all right, it would turn out the ship would be, instead of being 23,228 feet, it would turn out to be 405 feet. Okay? So think logically. A cruise ship is 1,000 feet long, and it's way out there because it subtends that really dinky little 2 degree, 28 minute angle. And you're saying, well, how far is the ship out at sea? You're saying a 1,000-foot ship is 405 feet out at sea. I mean, it would be right on top of you. Okay? That doesn't even make sense because the ship, you could not crunch it in your finger. It would be on top of you and crush you. All right, so just think about it and know when you're using something wrong, what a wrong answer comes out to be. All right, number 7. A jet is 30,000 feet up. So again, that's our distance. So what does the distance mean? That's the value of R. So there it is. So that is 30,000 feet. And it says it subtends at 1 degree 49 minutes. So 1 degree 49 minutes. It says how long is the jet? Well, that's this distance right here, math fans. So that's your S. Okay? So S equals 30,000 times theta. 1 degree 49 minutes. And of course, you got to convert that into radians, so it's going to be pi over 180 degrees. Okay, so S comes out to be 951 feet long. All right, and again, if you made a mistake and you forgot to convert it to radians, the jet that's 30,000 feet up would be 54,500 feet long. So the jet would be about 10 miles long, which is ridiculous. There's no jet that's 10 miles long, so that would be wrong. Okay, so I'm just trying to show you again what what's an error, what gives you an issue here. All right. All right. So the next thing we're talking about is called sector area, and this is what sector area is. It's a portion of the interior. Of a circle intercepted by a central angle. Intercepted by a central angle. Okay, a portion of the interior of a circle intercepted by the central angle. So let's kind of talk about where this comes from. Do you guys remember an area of a circle? Area equals pi r squared. Okay, and do you guys remember from geometry? Okay, I can say theta per 360 degrees. Theta is part of that circle, right? If I said half a circle, it'd be 180 degrees. But remember, to figure out a portion of that circle, it's theta over 360 degrees. So if I was talking about 90 degrees, that would be 1/4 of a circle. If I'm talking about 180 degrees, it's 1/2 a circle, etc. So it's theta over 360 degrees. And then let's convert it to radians. So it's 180 degrees per pi radians. And the formula we get is, if I cancel that out, that's a 2 and that's a 1. And the pi's cancel. And we wind up with 1/2 r squared theta. That's the area of a sector. Okay? And again, theta has got to be in radians. Okay, so you're given that theta because, once again, you want to know the area of the sector. What part of the circle? Is it, 350 out of 360, 180 out of 360, which is half a circle, etc. It's really pretty easy, but I just want to show you how it's developed. Okay, find the area of the sector. Okay, so area equals 1/2. R is 10 squared times 40 degrees. But of course, remember, it's got to be in radians. So it's pi over 180 degrees. And if I multiply all that out, I get an exact answer is 100 pi over 9 meters squared. And if I multiply all that out, I get 34.91 meters squared. That's the area of that sector. Okay? All right, last type of application problem is a gear and a pulley. We're going to be using S equals R theta a ton. And once again, I'm just going to remind you, theta is in radians. Okay? Super important. All right, so let's do the first one here. Pulley rotates 45 degrees as shown. How far will the weight raise if the radius of the pulley is 8 inches? Well, don't you guys agree? However much, let me put this in red here. However much this raises, let's say I raise it, I pull it up this much. Don't you agree that's going to be the distance that is the arc length here? Don't you agree that's going to be this arc length? So I'm really looking for the value of S. So I'm using S equals R theta. And I give you the radius of the pulley, so S equal, I'm looking for the arc length. What is this black arc length going to be on that pulley? So S equals 8 is the radius, times, I'm going to travel 45 degrees. Of course, it's got to be in radians, so it's pi over 180. So if I figure that out, it's 2 pi inches, or 6.28 inches. Okay? So that's a pretty basic one with just one pulley. Let's talk about gears now. Gears are actually pretty interesting. It says gear A is rotated 50 degrees in the clockwise direction. So we're going 50 degrees this way. How many degrees will gear B turn? So something that's super important here, math fans, is they're going to turn in a different rotation. But do you guys agree that if let's say this is 50 degrees here, if I rotate this 50 degrees, don't you agree it's also going to rotate, not 50 degrees, but it's going to rotate that exact same amount? So what's the same here, math fans? Isn't S the same? Okay, that's pretty key. So my arc lengths are going to be the same, but the rotations, the theta is going to be different. And of course the R's are different too. All right? So let's figure out our S for pulley A. That's what we really need to do, and then be able to transfer that to pulley B. Okay, so S sub A, which is the arc length of A, is 6 times 50 degrees times pi over 180. So S sub A is equal to 5 pi over 3. Okay, and remember that's the same, that SA is also SB. It's the same arc length. You've got to remember that with a gear like that. It's the same arc length, but it's going to rotate it a little bit different amount. I mean, if you look at, you can even look at it right now. Doesn't A look like it's rotating a big chunk, and B is only rotating just a little bit because it's a lot bigger gear. Okay, so that's what then S sub B is 5 pi over 3, and now what we're going to do is I need to find our theta, because I'm asking for how many degrees will gear B turn. So I'm looking for theta B. Right, theta A was 50 degrees. So it's going to be S equals R theta. So 5 pi over 3 equals, well, now it's 10 times theta B. Okay, and then I'm going to divide both sides by 10 or multiply by 1/10. However you want to do it, and theta B comes out to be, that's a 2 and that's a 1, so it's pi over 6. Okay, but that's not what we want. We actually want it in degrees, because that's what it's asking for. How many degrees will B turn? And that just means you convert pi over 6 to degrees, and we already know that. We should know that from yesterday, but if we don't, we're just going to say 180 degrees per pi radians. Okay, the pi's cancel, and we wind up getting 30 degrees. And that's the answer to that problem. So gear A rotated 50 degrees, and gear B only rotates 30 degrees. Okay? So those are the different applications that are important here. Have this sheet when you're doing your homework, and you should be good to go. All right? That's it, math fans. Have a great day. Adios. Goodbye.